Welcome to our new video series on creating a maze solver in Java. In this first video, we will be going ahead and implementing our first algorithm, which is going to be a depth-first recursive algorithm. So just a quick look over the algorithm. So in depth first, we will be following a path down a single direction until either the end is found, so we're done, or if we get a dead end, and then it should backtrack and return to the previous location. Kind of like with how Sudoku solver worked, that backtracking is going to be taken care of via recursion. And then we're going to do this recursively until either the end is found or we determine there is no solution to the maze. Okay, mazes are going to look like this. And then we have some code that we're going to take a look at. So in particular, our maze class. If we take a look at our maze class. So our maze, it consists of a two-dimensional array of node objects. Our maze class has a bunch of built-in, or I say built-in methods that I've written. So we'll be using these, and I'll be referring back to this code periodically because I forget which methods it has. Our node class is storing a row, a column, and then a character. And then it's also going to have a couple of methods, start, set end, walls, things like that, that we will be using as well. So to get started, we should go to our maze tester, and we're just going to run this code. So I'm making a new terminal here, and then compile everything in new Java, and then run maze tester. And so we see that every time we run this, I'm going to take a look at that maze. I'm going to run it again, and notice that the maze is different. So this is actually randomly generating a maze, which means that when we go to test later on, every time we run it, we're going to get a different maze. And so one of the things we'll add, if we have time, is it'll probably be after the AP exam, but if we have time, we'll go back and we'll make it so that we can read in a file that's a maze. So this week, we're just going to focus on getting a few of the algorithms done. We're going to get a depth-first search recursively and the depth-first search iteratively. Those will be the two algorithms that we get programmed this week. And in this video, we're going to do the recursive depth-first search. So looking at the maze solver class, we're going to go ahead and write our first method. So our maze solver is basically going to be a bunch of static methods. So we're going to say public static void, and we call this recursive depth first search. Now the reason for static is because we're not actually going to make a maze solver object. Instead, what we're going to do is we're going to call maze solver dot rec DFS on our maze. Okay, so like over here, we'll display it, and then we'll say maze solver dot rec DFS, and we're going to pass in our maze. Okay, now in addition to passing our maze, we're also going to need to give it some information, like what is our current location. So our current location is going to be the starting position. Now the default starting position in our mazes right now is always going to be in column 0, row 1. Okay, so we do row column, that'd be row 1, column 0. Okay, and then for right now, we're going to go ahead, and that'll be it for right now. Okay. So then after it's solved, we'll call maze.display. And so what we should expect to see when we run this now is we'll get the original maze, and then we'll get the solved maze. That's what we're expecting to see when this runs. Okay. So over here, that means we're going to get a parameter that's a maze. We're going to get an int, which is the row, and int, which is the column. Okay. Now, there's a couple things we need to check for here, right? So we're given this maze. We need to first off make sure, is the row and column we're given, is it on the maze, right? So we're going to check if row and column are actually in the maze, or I'll say valid. Right? We'll check if the node at row column is the finish. Because if it is, we're done. Right. And then if neither of those, right, so if the row and column are not valid, then we're done. Right? Are not valid. If row column is the finish, then we're done. Of course, if they're not valid, then we're going to return false because this didn't. So actually, I'm sorry, this needs to return a. So we're going to have this return a Boolean, just like how our Sudoku solver worked, right? So this method is going to return true or false based off of whether it read to a solution or not, right? So I'm going to go ahead and add that up here. So I'll just say return true if solution found and false otherwise. All right. Okay. And so then after we've checked if the columns are valid, row and column are valid. If we've reached the finish, if neither of those are true or neither of those happened, then we're going to go to we're going to go in the 4 directions. We're going to go down. We're going to go right. We're going to go down, right, up, left. Okay, that's going to be the directions that we check. All right. So how do we check if the row and column are valid? Well, we'll just say if row is less than 0 or column is less than 0, or if row is greater than what? Maze dot get, let's see, row has to do with height, so if you get height, or column is greater than maze dot get width, then we'll return false. Okay. Oh, you know what? In addition to checking, we also need to check. If node at row column is a wall, right? Or if it's been visited, right? Because the idea is we don't want to ever go back. So it's going to check if the current row or column is something we've already been, or if it's a wall, or basically if it's not empty, right? So if it's not empty and it's also not the finish. So what we'll do is we're going to check if it's the finish first, because if it's the finish, it's not empty, but that would be, we're done, right? So what we'll do is we'll say if, and inside of my node, inside of our maze class, we have a get pause that takes in a row and a column, and it returns the node at that position. Okay, so what we're going to do is we're going to say node current equals maze.getPause RC. So now we can say if current dot, and then we want to say is end. Then we'll go ahead and return true. We just solved the maze. All right. Otherwise, if we say if it's not empty, so if not current dot is empty, then we'll return false. Okay. And so if we've gotten to this point, then that tells us that we either, it's a valid point and it must be empty. Okay, so what we're going to do is we're going to say, okay, so if we've gotten to this point, then we're going to say current dot set visited, as in we came here. All right. And then we're going to check down. And so what we're going to do is we're going to say, well, return recursive depth first search, maze. Now down would be R plus 1, and then we're going to keep the current column. Okay. Now the problem with that is it's going to get to that return, and then that's the end. So actually, I'm sorry, we don't want to return there. We want to say if this, then return true. Okay. So what that's going to do, it's kind of going to do the same thing, except we don't want to actually return at that point. We want to check recursively going down, right? And when that finally, if it gets to all the way down and hits true, that means it found a solution. Once this is false, it's going to kind of go back up recursively, and it's going to jump, and it's going to try right next. And so we're going to do the same thing. If recdfs maze same row column plus 1, then return true. If recursive depth first search maze up would be row minus 1 column, return true. If recursive depth first search maze, let's see here, we want left, so that'd be same row column minus 1, return true. And if we get all the way through all of these and none of these return true, then we want to return false. Okay, so I'm going to save. I'm going to go ahead and compile and run. And so we can see the original maze followed by the maze filled in with the solution. Except if we look closely here, we can see that there's dots that aren't necessarily part of the solution. So what we want to do is, rather than leaving a node marked as visited if it doesn't work, is we actually want to mark it as unvisited. So the way we do that is inside of our maze solver. If we get to this last line right here where we return false, that means that this particular point didn't lead to a solution. And so what we can do is we can say current dot clear visited. And what that's going to do is it's going to remove the fact that we visited that node. Now we don't have to worry about going like literally back, because we're always moving down, right, up, left. We shouldn't get to a point where we get into a loop here. So now if we compile this, we run it, we should now be able to see that, let's see if we can find an example where it would, yeah, so here, see, it would have gone down first and then over, but since that didn't lead to a path, we only get the path that we traveled. Okay. The last thing that we're going to do here is notice how the S at the top becomes the dot, but the F at the end didn't. So to fix that, in addition to saying that we reached the end, okay, in addition to returning true, we're also going to mark current as visited. So current dot set visited, and then return true. So now if we compile and we run, we now see we have the path. Okay. So notice the similarity, I guess, to our Sudoku solver, and in the sense that we have this recursive call, and the backtracking is actually handled by that recursion, where we're calling the same depth first search algorithm in each of the 4 directions. So that's going to do it for this video. Thanks for watching, and we'll see you next time for the iterative version of this algorithm.